Hello. Today I'll just discuss about the Euler's functions. So first of all, define what is Euler's equation. The first point is understand the Euler's and function. What is first you understand the function. Understand the functions. And it is specially denoted by phi of n. Understand how to find phi n. Second point, understand how to find phi of n. So there are 2 points of Euler's and function. One is just define what is phi n function and how to find the phi n function. Phi n function specially represented here number of positive integers less than n. Number of positive integers. Number of positive integers less than 9. Less than n. That are relatively prime to n. That are relatively prime to n. That is represent the phi n and total number of positive integers is mostly less than 1, less than n, and that are relatively prime to n. Just we represent phi n. Example phi 5. Here represent n is 5. And just see n is 5. And just we can see the divisor of this 1, 2, 3, 4. So we can choose the GCD of 1 and 5, GCD of 2 and 5, GCD of 3 and 5, GCD of 4 and 5. Just we can see this value. Number of primes relative to given number. Here just we have to compute here GCD. GCD of 1 and 5. That is 1. 2 and 5. That is also 1. 3 and 5. That is also 1. And 4 and 5. That is also 1. Just you can see here all the GCD value is 1 relative to prime 5. Hence, how many numbers? 1, 2, 3, and 4. So, by 5 is equal to 4. And that is also, we can just define the phi n. That is equal to n minus 1. If n is relatively prime. That is also another process to find computing the value of phi n is equal to n minus 1 by using the Euler's functions, by Euler's function. That is phi n is equal to n minus 1. Phi 7, that is phi 5. Phi 5, that is equal to 5 minus 1. And that is also 4. And that is phi 5 also defined like this. And this is the general process, and this is by using formula process. Again, we come to another example, suppose phi 7. When we choose another example, phi of 7. So that is 7 is prime number. So this possible is 7 minus 1. That is 6. 6 numbers are present which is relative to prime. Just we can check here. The numbers are less than 7. Numbers are less than 7. Check here. 1 is 2, 3, 4, 5, 6. These are the numbers which is less than 7. Just we evaluate the GCD 1 and 7, 2 and 7, 3 and 7, 4 and 7, 5 and 7, 6 and 7. Just we compute the GCD value of each number. GCD 1 and 7. That is 1 relatively prime. 2, 7. That is also 1 relatively prime. 3, 7. That is also 1 and relatively prime. 4, 7. That is also 1 relatively prime. 5, 7. That is also 1 relatively prime. 6, 7. That is also 1 relatively prime. So all are prime numbers. 1, 2, 3, 4, 5, and 6. So what is 5, 7? The 5, 7 is 6. My formula is asking you this is prime number, then prime fn is equal to n minus 1. And that is also same process. 7 minus 1 is equal to 6. When it is a composite functions, what happens this? Phi 8 is there, suppose. Another example we consider here, phi 8. Check here. Phi 8 that can be written as 8 is not a prime. 8 not prime. So what we will do? So just we can less numbers number less than 8. Number less than 8 we can choose here. What are the numbers? 1, 2, 3, 4, 5, 6, 7. These are the numbers which are less than 8. So first of all, we find the GCD of 1, 8, GCD of 2, 8, GCD of 3, 8, GCD of 4, 8, GCD of 5, 8, GCD of 6, 8, GCD of 7, 8. Compare. So we compute the GCD. GCD, all value GCD. Compute that are not prime. So GCD 1, 8, that is equal to 1. 2, 8, that is equal to 4. 3, 8, that is equal to 24. 4, 8, that is not 24. There is no common value here. So that is 1. And 4, 8, GCD is 2. 5, 8, GCD is 1. 6, 8, GCD is 2. 7, 8. 7, 8, GCD is 1. These are the, so what are the GCD of prime factors? That is not 1 prime. This one is out. This number also GCD is out. This number is GCD also out. What is the remaining value here? 1, 2, 3, and 4. So phi 8 is equal to 4. Phi 8 is equal to 4. So just understand how to apply this formula for the composite number when is given. Eight is the multiple of 2. Phi of 8 or phi of n, that is also can be written as p minus 1 into q minus 1. If p and q both are the prime numbers, if p and q both are the prime numbers. Next, we have to discuss about, that is a one formula here. We have composite. Phi n is equal to p minus 1 and q minus 1, where p and q are the prime numbers, are distinct prime numbers. Distinct prime numbers. Remember, that is the distinct prime numbers. One example, 5, 5, 535. That is can be written as 5, 7 into 5. This is p and this is q. So that is 7 minus 1 into 6 minus 1 by the formula, and that is 6, and that is 5, that is 3, 30. That is the 30 numbers are there. 25, 5, 1000. That is also one formula when given that 7 and 5 are two distinct prime numbers, and when it is composite, suppose 5, 45, that is 9 into 5. And this also written 3q, 3 square into 5, 1. 3 is the one distinct prime number, and this also distinct prime number. Then this is 3 minus 1 into 5 minus 1 is equal to 2 into 4. That is 8 different ways we have to compute. But in the case of composite number, what we'll do here, composite number. When we consider, what is the composite numbers? Phi n can be written n into 1 minus 1 by p1, 1 minus 1 by p2, dot, dot, dot. P1 and P2 are distinct prime numbers. P1 and P2 are distinct prime numbers. P1 and P2 are distinct prime numbers. Just one example we consider, phi 1000. That is of phi 1000 can be written as 2q into 5q. Check here, 2 and 5 are the two distinct prime numbers. Then define what is n here. N is 3. N is 1000. So 1000 into 1 minus 1 by 2 into 1 minus 1 by 5. Then what is its value? And that after simplification, this value and found the 400. And this is basically, we say that actually this is the Euler's type of functions. How to evaluate this one? Now just I'm going to Mobius functions. What is Mobius functions? Mobius functions specially denoted here mu n must greater than 1. This is called as the Mobius function. And Mobius function mu is defined here. 1 we consider when n is equal to 1. 0 is considered when p square divisible by n. Just p here defined prime number. And minus 1 to the power r we consider when r is equal to p1, p2, p3. Distinct prime numbers. These are the distinct prime numbers, whatever we define here. And that is called as the Mobius functions. We just calculate mu1. Just see this formula. Mu1 when defined means that is 1 when defined here. Mu2 mu2 is applied here. 2 that is p square, that is also 0. Mu2 p1 and p2 are the separate distinct prime numbers, right? For r is 1, so minus 1. p3 mu3, that is also distinct prime numbers. p3 is the distinct prime numbers, and that is 3. Mu3 also minus 1. Mu4 2 square, that is mu2 square. Mu2 square, that is 0. Mu5 that is also 0 because distinct prime number is given. Mu5 that is minus 1. Mu6 2 into 3. 2 into 3 distinct prime numbers, minus 1 into minus 1. That is 1. So like this, we compute the Mobius functions and just define the statement of Mobius functions also. Thank you for watching.